You are welcome to my physics channel once again. I'm going to solve a very good question on heat capacity. And this is the question. The question reads, two metals P and Q are supplied with the same quantity of heat if the ratio of the specific heat capacity of P and Q is 3:1 and the masses are in the ratio 1:2 respectively. Calculate the ratio of the temperature rise of P to Q. Don't forget that this is question for WAEC 2021. We are going to solve it here. Listen and pay attention. Alright, solution. Now let's go back to the question again. The question says that it's talking about two metals, which is P and Q. And this P and Q have the specific heat capacity in the ratio of 3:1. So I can now write C of P to C of Q is equal to 3/1, which means the specific heat capacity of P is 3 and the specific heat capacity of Q is 1. Then the question further says that this P and Q, they are in the ratio of their masses as 1:2. So in terms of masses now, we can have MP is to MQ is equal to 1/2. Now using the relationship between heat loss is equal to heat gain, we can have MP times the specific heat capacity of P times the temperature change of P is equal to the mass of Q times the specific heat capacity of Q times the temperature change of Q. Now let's substitute in the values of the mass, the specific heat capacity, and then the temperature respectively. So for P now, mass of P is what? Is 1. So I can write 1 times the specific heat capacity of P is what? Is 3. So I'll write 3 here times the temperature change of P is equal to the mass of Q is 2 because they are denominators. So we have 2 times the specific heat capacity of Q. From the relationship we know that is 1. So that is 2 times 1 times the temperature change of Q. Understand that the question is demanding for the ratio of the temperature of P to that of Q. So when you have 1 times 3, it will give us 3. And 3 times QP will give us 3QP. 3 times the temperature of P is equal to 2 times 1 is 2 times the temperature change of Q is 2 theta Q. Now, first of all, the question is demanding for the ratio of P against that of Q. So we are dividing both sides by Q. So if we have 3 theta P divided by theta Q, it will be equal to 2. Now, to make the temperature of P and that of Q the subject of the formula, you divide both sides by 3. And by doing so, I can have theta P over theta Q. Theta Q is equal to 2 divided by 3. Now, we have gotten the ratio. So, writing it in the ratio form, we can have theta P is to theta Q is equal to 2:3. So, this is the solution because the question says calculate the ratio of the temperature rise of P to Q. So, this is the temperature of theta P to that of Q. I hope you enjoyed this solution. Please, if you enjoyed this solution, don't forget to subscribe to my channel, like the video, and then share it. Put down your comment. Love you. Have a lovely time. Bye.